After working through the major steps of the geologic model, we need to decide if our geologic model is sufficient. Meaning, is it accurate? Can we trust it? Can we make plans based on it? We have a lot of tools available for that: contouring, cross sections, 3D inspection, but it's ultimately up to the person making the model to determine if that model is sufficient. Oftentimes, your first attempt at making the geologic model is not going to be perfect. You may need to refine that model, and you may need to loop through these steps again and again, adding in additional information or making corrections where needed. And a large portion of this video is going to focus on some of the other tools available to you in the program. I'm not necessarily going to show how to use all those tools, just want to make you aware that they are in the program. One of my favorite quotes with regards to geologic modeling is made by George Box. He said that all models are wrong, some are useful. So there is no such thing as an absolutely perfect model. We are trying to understand what's in the ground based off a very limited amount of data, and that's inherently going to have some error in it. So it's our job as geologists, as engineers, to make the most correct model that we can. Now, there is no go button when it comes to geologic modeling. What you did for the last project may not apply to this project. So that's why it's important to know about all the different tools available to you so you can make the corrections that you feel you need to make. I want to specifically talk about the modeling concepts listed here. I've already discussed some of these in previous videos, but we're going to rehash some of those, and you can see some of the settings that are available. These can be available in Carlson Configure mining settings. These can also be available in the Strata definition files and a few other places throughout the program. First concept I want to discuss is strata versus beds. Strata names are always required in the drill holes. Strata simply tell us what type of material is this. Is it coal? Is it shale? Is it limestone? Is it clay? What is it? Sometimes you can get by modeling only off of the strata names. Only for very simple projects is that possible. For more complex projects, you need what I am still calling an optional identifier of the bed name. Even though this is optional, many projects do require a bed name. A bed name groups multiple strata layers into a single mining unit or a single modeling unit. And with that, we're trying to answer the question, what specific formation is this? So if you have several layers of coal that are all part of the same seam, we could give those a bed name of the Pittsburgh coal seam. If you have a large portion of limestone, maybe it was sampled on regular 5-foot intervals, that might all be part of the Joliet limestone bed, things like that. I've got some examples here of when strata names are acceptable and when strata and bed names are required. So in this first drill hole, we just have one instance of each strata name, and they don't repeat. So A, B, C, D, that's perfectly fine. We could very easily correlate one drill hole like this to another drill hole with one instance of each strata layer. If the strata names repeat, however, A, B, or even if they repeat, even if they're next to each other, so A, B, the simple matter of the strata names repeating means that we would not be able to model based only off of the strata names. We could still draw the drill holes, we could still label them, but we wouldn't be able to make a geologic model off of that. And actually, if we tried to make a model off of that, we would get an error message telling us about that problem. So for instances like this, we would have to have a bed name. And a bed name simply groups all those strata layers together into one larger group. Notice, even though I have repeating strata names, because these are all part of a single bed, program is able to work with that. Because when we create a bed name, we're not necessarily looking at the strata names anymore. I'll talk more about that in just a moment. But there is still a rule with the bed names, in that bed names cannot be interrupted by other beds. So if we had a bed name in the drill hole of 1, 2, and 1, 2, that would not work, create an error, because we are not able to interpolate and to connect up data points when we have bed names repeating like that. I will mention you can have gaps in the beds. So if you have a layer of bed 1, a gap with just a strata name, and then a layer of bed 2, that's perfectly fine, so long as the bed names are not interrupted. Now with regards to the way the program thinks about beds and strata names, when a bed name is used, we're really not looking at the strata names anymore. Instead, we're looking at the key, non-key status, so is it waste or is it not waste, and the position of that layer in the hole. When we create a model and a bed name is present, all parts of the bed name get classified into one of 4 different groups. The key group, that is simply all of the key material lumped into one group. The parting group is all of the non-key material that is actually sandwiched between layers of key material. So these 2 layers get grouped in the parting group. The OB, or the overburden group, that's all of the non-key material that exists above the first occurrence of key material. The bottom group is all the non-key material that exists below the last occurrence of key material. So if we were to model this drill hole, we wouldn't be able to model individual layers of coal and shale. We would be able to model these 4 groups. Now, not all data sets will have all 4 groups. It's very common to see just a key group and an overburden group. Very common. So it's not a problem if you don't have the ability to model all 4 groups, because it may simply not exist in your project. The specific naming for these groups of OB, parting, key, bottom, these can be changed under Carlson Configure mining settings. So you can change those suffixes if you like. There are plenty of tools available for you to find where you have repeating strata names or maybe interrupted bed names. Under reports, there's an invalid strata report that will tell you what the problem is and which holes it exists in. And to actually correct those problems, you could make changes to the names manually, but there are some very good tools found on the drill hole pull-down menu, strata bed utilities. A lot of good tools in here for renaming beds, renaming strata, grouping things together, breaking things apart. A lot of good options available for you there. The next concept I want to talk about is the pinch-out option. In this cross-section, we have 3 drill holes. Drill hole number 2 only has the red, the yellow, and the black strata, whereas drill holes 1 and 3 also have a blue and a green strata. If we turn off the pinch-out options, we may see some strata layers exist in areas where they don't actually exist in the drill holes. So in this case, both the blue and the green strata are carrying through this hole, even though we didn't actually see that strata in the drill hole itself. So by enabling the pinch-out, we can affect each of those grid files to ensure that the blue strata doesn't actually exist in that area. Now we could make this just with elevation grids to get a behavior like this where the blue strata pinches out right at the drill hole there, or we could do some custom grid manipulation to actually make that blue and that green strata pinch out halfway between the drill holes. That's a very simple calculation you could do with grid file utilities. I'm not going to go into that right now, but it is a very easy process. The pinch-out settings are shown under Carlson Configure Mining Settings. We have an option here to turn pinch-out on or off. We have a slider bar here to actually determine if the pinch out occurs halfway between the drill holes, or if it occurs closer to the known data point or closer to the missing data point. So you can actually move that slider bar to control how far away the pinch out occurs. There's a few other options on here. We have explanations for those in the help manual, but we do have a lot of control over how you can apply this concept. The next concept I want to discuss is horizon codes. So horizon codes are often used to account for bad data points, or maybe just data points we don't want to use in the model. In this cross section, we have 3 drill holes. Drill holes 4 and 6, we're able to drill all the way through the green strata and into the black strata. Drill hole 5 only got a portion of the way into the green strata. If we were to model all of those data points, we would see this green strata get pulled up to the bottom of this drill hole. And because we only partially penetrated that strata, that's not a very desirable behavior. So by adding a horizon code to this specific data point, we can ignore that data point and make a more realistic model. Now, horizon codes are nothing more than an extra strata attribute, just like if we were adding a density, a BTU, a moisture attribute to a strata layer. Same thing for a horizon code. You can define these however you like. I often just refer to them as horizon, and then I put a value of a 0 or a 1 on there, just some integer value. Once the horizon codes are added, you do have to actually tell the program what a horizon code of 1 means, what a horizon code of 0 means, and we do that on the drill hole pull-down menu under Define Horizon Codes. That command opens up a dialog that looks like this. It'll be blank initially, and you can add to bring up this dialog where you define each individual code. Here I'm about ready to define a horizon code of 1, meaning anytime I've got this horizon attribute set to a value of 1, I'm not going to use the thickness, and I'm not going to use the elevation. So we're essentially ignoring that data point for thickness and elevation, but the data point will still be used for modeling other qualities. For example, if I was trying to model the BTU on that data point, this value would still be used even though the thickness and the elevation are ignored. You can apply different descriptions if you like, but oftentimes just adding a single horizon code is sufficient for ignoring data points. The other thing to note is that the horizon attribute name listed here does have to match the attribute name found in the drill hole. Next concept I want to discuss are strata polylines. Strata polylines are a means of modifying the data to make your strata layers behave in a specific way. We can see here on the left that I've drawn a cross section just based off of 2 drill holes. But if for some reason I thought that the green, the yellow, and the black strata layers behaved more like this, I can just simply create a strata polyline, tag it for each individual strata, reprocess the model, and I could make my model do something like this. This could also be useful if you don't actually have drill hole data. Maybe you're trying to digitize old geologic cross sections. You could use strata polylines for that. There's no special settings required for it. It's just a simple matter of drawing the polyline in 3D space and tagging the polyline, tying it to the specific strata. When working with strata polylines, it's often useful to work with profiles, meaning on the previous slide, if we were to simply draw one of these black lines, we could use those profile tools to convert this 2D polyline into true 3D space. So we've got some good tools in the survey and the civil module for working with that. The general workflow when working with strata polylines is to start by drawing a cross section, to draw polylines on the cross section that show where you want the strata to go, to use this profile from polyline on profile grid. That command converts the 2D polyline into a profile file. Then we could use profile to 3D polyline to convert that profile file into a 3D polyline in true 3D space. Essentially, these commands just take a 2D line to put it into the correct 3D space for us. We then tag the strata polylines and recreate our strata grids to make the model. The next concept I want to discuss are strata limit lines. Now, these are not to be confused with strata polylines. A strata limit line allows you to limit the existence of a strata layer to a specific area. Now, this is not the same as a pinchout, where a pinchout gradually reduces the thickness of a strata layer. A strata limit line is a hard cutoff. For example, if you were trying to model a coal washout, if you wanted to just mark a boundary and say, anywhere inside of this boundary, I'm just going to assume that there's no coal, we could use a strata limit line for this. So here we have a cross section where the blue strata simply ceases to exist whenever it hit the boundary. It's just another option for limiting that blue strata. There is an option found for this under Carlson Configure Mining Settings, so we do need to actually turn the strata limit lines on to use them. And I also like to use this auto select all strata limit lines, so you can just continue working, you don't get any extra prompts for them. But the general workflow for working with strata limit lines is to draw a closed boundary where you think the limit line exists, and that limit line could be either an inclusion or an exclusion boundary. We would then simply name the strata limit line to tag it for a specific strata layer. And it is important to note that regardless of what the grid shows inside or outside of those strata limit lines, the actual cutting of the strata is always performed on the fly. So you don't have to actually change your grid values. You could simply make a model, you could draw a strata limit line, redraw a cross section, and it would, on the fly, modify that cross section to ensure that the strata doesn't exist inside the area that you specify. Next concept I want to discuss are faults. So this accounts for breaks in the geology where some material has been uplifted or thrown. We can model both normal and thrust faults. Now, a fault in Carlson is nothing more than a polyline that is tagged with a dip and a shift. So here I'm just looking at a vertical fault. So we have a very hard cutoff in the grid that just ensures that we have a nice clean cut there. The general workflow for faults is to start by drawing the polyline to define the location of the fault. Now, the direction you draw that fault polyline does matter because that'll determine if the left side is higher than the right side. Just know that whenever we specify a positive fault shift, we expect the left side of the fault to be higher than the right side of the fault. You can also specify negative fault shifts. Just know that the direction of the fault line does matter. Once you've drawn the fault polyline, you can either calculate the fault shift automatically based on the drill holes, or you could manually insert the amount of fault shift at each vertex on the polyline. Got two commands there for that. Once the fault has been tagged, you could simply recreate your strata grids, and those strata grids would be modified with the fault break. The next concept I want to discuss is seam splitting. So this allows you to split one strata layer into multiple child strata. So here we have strata ABC that breaks into strata A and BC, and then eventually into A and B and C. So seam splitting is actually defined in the define strata bed command. We saw that in a previous video where you had the ability to define a top split or a bottom split. It's just important to note that when defining a top and a bottom split, those strata layers need to also be defined later on. Now, when a split has been properly defined, when you attempt to actually make the model, showing this dialog here where I'm getting ready to model each of the strata layers, I would only have the ability to model the child strata. When those strata layers come together to form the parent strata, the program automatically accounts for that, reports your reserves accordingly, but when actually modeling, you would only be able to model the child strata. Seam splitting does often require you to account for pinchout. As we mentioned earlier, when you're modeling pinchout, you may need to use grid file utilities, or you could use a grid file utility macro to account for that pinchout. Specifically, when we're modeling the interburden layers, we need to make sure that that interburden pinches out where strata A and strata BC come together. So that is a common part of modeling seam splitting. The next concept I want to discuss is conformance. So conformance is a concept that also allows you to account for incomplete drilling. But it's important to note that this is pretty much the opposite of the horizon codes we discussed earlier. Where horizon codes were removing faulty or incomplete data points, conformance actually inserts additional data. We're not ignoring, we're inserting additional data. For this reason, the first time I make a model, I like to turn off conformance so the program doesn't try to make any modifications, but you might find in certain situations that conformance can really make your model behave the way you want it to. And what conformance will do is, on drill hole number 6 here, we've only gotten down to the yellow strata. Maybe we simply couldn't drill deep enough to get into those other strata layers. But if we notice a trend in the other strata, notice how all these strata are dipping downwards, I could use conformance to artificially add a green strata layer onto this drill hole to make the model behave the way that I want to. So again, we are artificially adding data to the drill holes when we make the model. Now, conformance does give you some flexibility. You can tag strata as markers or as targets. A marker strata is thought to be the dominant strata layer. Basically, your targets will mimic the behavior of your markers. These options are defined in the define strata bed command, where you can set each individual strata layer as a marker, and you can also specify which strata layers are going to mimic that strata layer. So here I have strata C1 set as a marker. Strata C2 and strata UB are going to mimic the behavior of strata C1. There's another option found under Carlson Configure Mining Settings where you can actually tell the program to do the seam specific option. That simply means use whatever option I define in define strata and bed. You could alternatively turn conformance completely off, or you could set it to all, in which the program automatically applies conformance for you. My general preference is to use seam specific so I can absolutely determine what's the marker, what's the target. Just another example here for showing how conformance works. In this diagram I have 3 drill holes spaced at different parts of the mountain, and I've got my red, my blue, and my green strata. I have 3 data points for the green strata, meaning I can model that more accurately than I can a strata layer that just has 1 data point. If I tried to make this model without conformance, my red strata layer would draw completely flat because we have no indication that there's a slope in it. Green strata would model with a slope following the data points. But if I have reason to believe that my red and my blue strata mimic this green strata, I can use my conformance options to make that happen. So with conformance turned on, at drill hole number 3, the program actually goes out to the surrounding drill holes. It determines what the distance between the green and the blue strata is, and it uses that same offset at drill hole number 3 and artificially inserts this blue strata data point at that drill hole. That allows the model to follow the behavior of the green strata. It would do the same thing for the red strata layer. So conformance is a really nice option to make some strata layers behave like other strata layers. So again, these are just some of the various modeling concepts you can use to refine your model. After incorporating some of these, you would need to go back through the process of creating your grid files, which would update your geologic model, and then you could again go through your steps of determining, am I satisfied with this model? Once you are, you could move on to the surface mining module or the underground mining module to actually begin your mine planning.